In this video, we're going to be going over how to write the names and chemical formulas for compounds which are ionically bonded. In particular, we're going to talk about binary compounds, which are two-element compounds. In future videos, we'll talk about what happens when your ions have multiple elements in them, and what happens when you have special metals that can have a multiple number of charges. For this video, you're going to need something to take notes with, something to write with. A periodic table and chart of charges would be fantastic if you have them. If you don't, please pause the video until you get them. And if you are ready, let's go. Okay, so the first thing we should probably talk about is what a monatomic ion is, right? Ions, remember, are charged particles. Monatomic just means that they're one atom ions. So a cation, reviewing from what we picked up on in chapter 3, is just any element that loses electrons and forms a positive charge. These are almost always going to be metals. To name a cation, it's actually very straightforward. You just take the name of the metal. That's also the name of the ion. Right? So aluminum, which I told you in chapter 2 when it forms an ion, forms a +3 ion. We just call it the aluminum ion. Li+, because everything in group 1 is +1, is the lithium ion. And beryllium, because it's in the second group, is a +2 ion. That's just called the beryllium ion. Right? So those are very straightforward to work with. Anions are negatively charged. They gain electrons, so they're going to be primarily nonmetals. Now, to name a negatively charged ion, what you do is you take the root name of the element, you drop the ending, and add IDE. Right? So N is the nitrogen atom. N-3 is the nitride ion. O-2 is the oxide ion, whereas O is just oxygen. All right, and F- will be fluoride. Please pay attention to elements like sulfur and phosphorus, because when you rename those, you may have to change the spellings or pronunciations a little bit to make them a little easier to work with. Okay, so these are our single atom ions, and what we're going to do is we're going to combine these together to make compounds. So again, ionic compounds composed of two ions, a plus charge and a minus charge. Now, again, harkening back to when we talked about compounds in atomic structure, compounds are electrically neutral. That means overall they have no charge. Right? So another way of saying that is for every positive charge you have in the molecule, you also have the same number of negative charges, right? So they have to balance. And the goal behind writing formulas is figuring out what the lowest ratio is to get those charges to cancel out. So if I have a +2 charge, I need some way to get a -2 charge to cancel it out. So if I have a -2 ion, you just need one of them. If I have a -1 ion, then I need a pair of them. Now, the way that we're going to go about doing this is by using a technique that we call drop and swap. Right, so this is the easy way to do it. This is basically working off of least common multiple. So it's a little bit of a shortcut. The way that we do this is we start off by writing the symbol in charge for each of the ions in the compound. Now, after this, I'm going to go through a handful of examples. I'll do a couple and I'll have you try a couple. When you write your symbols, the positive charge always goes first, the negative charge always goes second. Once you've written the symbol in charge, then what you do is you remove the signs. The reason why is because when we go to drop them, we make them subscripts later on. You can't have a negative number of atoms, right? It's not possible to have less than 0 of something. Then you reduce the charges to their smallest ratios. So if I have a 2 and a 2, those will reduce down to 1 and 1 because each number is divisible by 2. If I have a 3 and a 2, though, I can't reduce those down any farther than they already are. Right? So we're going to reduce them down, divide them both by the same number, and you should be good there. And then the last thing we do is we drop the number down from being a charge or an exponent to a subscript, and then we swap it over to the other side of the compound. Right, so drop and swap. Basically, what we're going to be doing is another way to say this is crisscrossing. Right, so if I have, for example, atom A and atom B, and let's say atom A has a 2 here and B has a 3 here after I do all my reducing, all I'm going to do is the 2 will come down and across to be the subscript for B. The 3 comes down and across and becomes the subscript for A, right? And I would wind up with A3, B2 is my formula. That's all there is to drop and swap. Literally just cross them down after you've reduced them. All right, so I'll do a couple of examples, and I'll have you guys do a couple. But first, we should probably get into naming, right? Because we do have to learn how to name things. Naming a compound, an ionic compound, is easy. You just name the two ions, positive first, negative second. Right? So, again, we went over how to name ions. Just write the two in order. So here are some examples. So calcium nitride. Now, calcium on your periodic table is Ca, and because it's in group 2, it has a charge of +2. It doesn't matter whether you write +2 or 2+, whichever one works better for you. Nitride is N, and as we've already seen in this video, nitride has a charge of 3-. So what I'm going to do is, first step, I've written the charges. Now I'm going to get rid of the signs, right? So now I'm going to get rid of the plus here and the minus there, leaving myself with 3 and 2. 3 and 2 cannot be reduced down to a lower ratio, so I can't do that. So now I do my drop and swap, right? So 2 and 3, and I'm left with Ca3 N2 as my formula for the compound calcium nitride. Now what I want you guys to try, take a couple of minutes on this one, is try magnesium sulfide. Okay, magnesium sulfide. We're going to start off with a magnesium ion. Magnesium is Mg with a 2+. Sulfide is S with a 2-. Now you notice something happens here. +2 and -2. They naturally cancel each other out, right? So if I go through this process, what I'm going to do is I'm going to get rid of the plus. I'm going to get rid of the minus. And then 2 and 2, well, 2 and 2 can reduce down, right? I can do 1 and 1, and I would drop and swap, but we're lazy, so we don't write 1s. And we just wind up with MgS as the formula for our compound here. So that's all there is to doing drop and swap. It's that easy. Right, so now what we're going to do is we're going to go through, we're going to name a couple of compounds. So I have CdI2. All I have to do is name the two ions. Cd is cadmium, and I is iodine, but remember the last word gets changed to ide, so this will become iodide. Right, so CdI2 is calcium iodide, or cadmium iodide, sorry. So how about you try KCl? Again, pause the video and pick it up when you think you have an answer. Okay, so we'll start off with K. K is just potassium. And then Cl is chloride. Right, so KCl is potassium chloride. So this is working with binary ionic compounds, right? Not that bad to work with. In the next video, what we're going to do is we're going to expand some of our ions to be more than one element and use what we call polyatomic ions. I will see you guys then.